as a community, we've done such a good job of kind of holding a diversity of ideas in how we build GraphQL servers together. And you heard a lot today about code first, or schema less, or how you should do it. And I want to encourage everyone to take a look at what works best for you and for your team. There isn't a single way to do GraphQL right. It really needs to fit what your team is, because it's all about building for your product. So it's been really awesome to be part of this community. I've been a part of it really since the beginning of GraphQL being open sourced, because I work at Apollo. And for those of you who don't know, Apollo is a company that builds tools and libraries, both open source and commercial, for GraphQL and for teams using GraphQL. And I happen to have the immense privilege of leading the open source team at Apollo, which means that y'all are all our customers, the people that we work for and we work with. What I'm going to be talking about today is essentially largely driven by hopefully meeting your needs well and working with you to understand what it looks like for your team and your company to adopt GraphQL. So what I'll be talking about is Apollo Federation. I'm sure you've heard from a couple talks yesterday and this morning referencing this talk, and that makes me really excited and also really nervous, because now living up to what Marc-Andre said and kind of gave was a big pressure. But I'm excited about it. A federation is our successor to schema stitching, and it is a way for organizations to build a single monolithic data graph with a number of different teams, a number of different services, and all sorts of different languages, but ultimately be able to coordinate and work together on building a single collective data graph. And there's a ton of value in how we structure our companies. I mean, Conway's Law is definitely a very real thing, and the ultimate things that we build is reflective of who we are as people. And companies over and over have seen that being able to group people with a known domain expertise and a known responsibility is a really effective way to build products. But what we feel like has been missing in the GraphQL world is a way to echo that structure into how you build your product. We first tried this with schema stitching. Schema stitching was a wonderful experiment that I think was really successful in figuring out what not to do, which is a really critical thing as this young community develops, to have the freedom to explore these ideas and to try them out, and then realize, you know what, that really wasn't it. Because GraphQL is not done. The answers are not all there, and we're kind of working collectively to figure out what that looks like. But schema stitching, we feel like, was the wrong approach because it was answering the wrong problem. It wasn't how do we collectively as a team collaborate on a single product for our clients to consume. How do we work with our client teams to build the right graph? It was, how do I take a gateway and own these different parts of the services and remix it into what I want? You had to write all this brittle code in the gateway. It became very heavy. It was hard to coordinate between teams. And ultimately, it missed the mark on what the real solution for teams was. So we knew this. We heard it from the community. We've seen schema stitching being adopted by a lot of people. It powers a lot of products that you probably use day in and day out on your phone today. But it still wasn't right. So we kind of said, OK, this isn't right. What do we do here? How do we work with the community to figure out what a better solution is, and how can we work with them to get it built? So we tried to work back from an idea of core principles. What is the principles of federation, if you will, here? And the more that we talked with companies using schema stitching or investigating it, the more we worked with the community on this, there were four main things that really started to come out. That federation should be declarative. You should be able to separate your code by the proper concerns for the teams that own them. It should still be client-focused. The end result here is a schema that is a shared collaboration between your client teams and your services teams. And it should ultimately just be GraphQL. You shouldn't have to introduce a whole new language, a whole new syntax. You should be able to use that core language that teams use to communicate together. These guiding principles are really, really valuable. So we want it to be declarative. We want teams to be able to walk through and give their capabilities to the rest of the organization. It isn't about ownership. It's about contributing collectively to an overall data graph for your company to use. We want it to be separated by concerns. Teams need to be able to work in some level of relative isolation. It's not a total isolation. But they need to be able to deploy on their own. They need to be able to test and run their services on their own without having to work in a larger, giant monolithic picture. And for some companies, that really is the best way for their teams to work, and they've been really successful with that. It needs to be client first. This has always been something at Apollo that we've felt very strongly about, that you should work with the people consuming your API to develop it. GraphQL is an API technology, not a database technology. It is about that experience of working with your data from the client teams and doing interactions there. And it should just be GraphQL. And the real thing about being just GraphQL is that this is be something that the community should feel that they own and that they can contribute to and be part of. So this isn't something that's limited to JavaScript or Java or Go. It really is just part of the language itself. So every language that works with GraphQL is able to work with Federation. And ultimately, we started to look back at these principles, and we realized that we had wrote the same principles that we give to people when they ask us for advice on how to build GraphQL with a monolith. It's those same things. You still want to be able to build your schema in a way that makes sense for your clients. You want to be able to declare it. That's where we like the SDL approach as a way to do that, but that's just one way to be successful in it. And you may end up starting to look something like this, where you have these three types: a user type, a product type, and a review type. And ultimately, this is a pretty simple schema. Obviously, yours is much more complex, all the way up to 30,000 types. But there's a few really good things that come out of the language itself when you start to look at this. You're able to declare and read what your users can access. You can form an actual data graph. You can have references between the user type and the reviews type and the product type. But the problem with something like this, if you draw the lines there, which is what more and more we're seeing teams do, is they draw types as that boundary between their teams, is you actually miss the mark of what makes GraphQL really successful and how people can work together on it. And ultimately, what we think is you want something that looks a little bit more like this. So ultimately, this is the same schema. Everything looks the same. But the difference here is that you're segmented out by the domain expertise of teams. This is where we talk about proper separation of concerns. You have a team that is responsible, has domain knowledge, is on call for the accounts portion of your app. You may have another team that does the products, and another one that does the reviews. But what they need to be able to do is the products team needs to be able to relate and extend what the user can do. How many here are familiar with the extend keyword in the GraphQL language? Great. That's a lot more than I expected. That's awesome. It's a really powerful way to say, to collaborate on types together. And so we really want that to be part of what it means to share concerns within GraphQL. The same thing for the reviews type. Not only do I need to be able to extend what a user is and add new capabilities to them, give them the reviews, same thing for product, give product reviews, but it needs to be able to go both ways. The review type needs to be able to reference the user type because they have an author. And it needs to be able to reference the product type because ultimately we still are trying to create a data graph. And that's where this thing comes from, right? So what if you took this and you're building an app with it? One of the first things you may do is build it all in one file, start out really early. Then as you progress, you start to get more and more objects in your code base. You start to get more and more files. And you start to break out into modules that look like this. GraphQL modules is a really great way to show this kind of relationship. But for some teams and for some companies, you want to go farther than that. You want to be able to say that my account service is actually its own runnable service. It's written in Java, because that's the service that we have all of our account system on. You may want to add a new service for reviews that is written in Node, because it's a brand new service and you want to try out that language. Or maybe it's the best fit for the job there. And what we want teams to be able to do is to work with their legacy systems, because we all have them. That's how we got here. That's how our products are. Those are the systems that gave us the revenue to come to this conference and to build our apps. And we can't throw that out. We can't build this pure, beautiful, simple GraphQL layer on top of all of that, because we live in the real world and we have to be able to work with our real world circumstances. So let me walk you through what Federation actually looks like in practice, kind of the what happens when you apply all these things into a distributed architecture. So we'll go on a little spacewalk over here. All right, can everyone see this okay in the back? Cool, all right, thumbs up, great. So what I have here is a running gateway, and then I have 3 services. So here's my account service. This is just what I showed on the other slide. It's pretty simple. It's an entry point into the graph to grab a user, and it's a couple details about the user. And for right now, just ignore the directive. We'll get into that a little bit later. But this is just a pretty simple schema. In fact, I can come over here and let me delete this. And I can run it. And this service is totally runnable on its own. But this is a federated service. It's only part of the overall graph. But you don't need the gateway to run it. You don't need the gateway locally to test it. The team can work in their isolation with their tool chain to be able to work on it effectively. So then I have the review service. And again, this just mirrors what we talked about a little bit earlier. But one of the key things here is I can start to extend the types from other services. I can start to extend the user type and add my own capabilities to it. And then we have the product service. which is super simple. I mean, it's pretty much as simple as the user service. It has a new entry point into the graph, and it has some details about the product service. The product service has no idea about the review service. I mean, they do, because they work together as a company. This isn't totally isolated. We're not talking about like building in the dark, but their responsibility is focused on just what they need to be able to do with the product service. And again, you can query this as its own standalone service. So I think where things get really exciting for me as we've been building out this and working with our partners on exploring this is, what does it actually mean when you start to execute against this graph? So we'll start really small. We'll add the name field here, and we will go and fetch some information from the account service. So this is pretty simple, right? Yesterday, Marc-Andre talked about one of the ways that schema stitching is done is essentially creating a GraphQL proxy, saying at the root level, I know which fields need to go to which service, and that's a pretty easy thing for me to build. And you can see we've kind of effectively right now have done something similar to that. I've only fetched data from the account service, and so I get the data back, and then I have this new thing in GraphQL Playground called the Query Plan Viewer. And I can see what the gateway, in this case the Apollo Gateway package, is doing when it receives this query. It's going to have a query plan that will fetch from the account service, and it will select the username and the name. And that's pretty simple. It's a straight up proxy at this point. Nothing super crazy about that. But if we look at the review service, one of the things that we can see here is that the review service extended what a user was, and it added new capabilities to it. That's part of declaring, the declarative model of Federation is that it can declare its capabilities to the overall graph. So it adds this reviews field. And if we go to the account section, and we look over here at the schema, sorry for turning my head around a little bit, you can see that there's a user type, and this user type doesn't have a reviews field. It's just a part of that overall shared type ownership. But when I go back to the gateway, and I look in here, then sure enough, I have a reviews field, and I can load the body from it. So I'll go ahead and execute this. So this isn't a new entry point. This is within the graph, a extension of a type, and then the addition of a new type that is owned by a different service. So all the data resolves back as you would expect it to. Again, it's just GraphQL. In fact, one of the core things here is that your client should never actually know or care if you have a monolith or a federated service, or if you have one really big chunky server and a couple small services like search running on the side of it. None of that really matters to the clients. What they should be able to do is use GraphQL, ask what they want, and get the data back. But what gets really cool here is that now I am fetching from the account service. And if you've noticed, I've added two fields here, the type name and the ID. And this isn't something that the client asked for. At this point, this is how we've created a dependency between these two services. And then using that information, I can go to the review service, and I can enter into the user type that the review service knows about. And it only knows about the reviews and the ID so that it can fetch the reviews. So at this point, I have a query plan now that can show me the exact work that's being done by the gateway. Because we've known from the beginning that tooling is a very big part of what makes GraphQL successful. And if you're going to enter into a world where you want to use Federation, and again, we've worked with a lot of teams who it's absolutely the right fit for them, and they're really excited about this, you still need the tools to support that really well. So let's go a little bit further here, and let's go into some level of a proxy. So I'll fetch the name on top products. And again, this is a root field. But now I have a new node in the query plan, which is parallel. So the gateway can chunk up this work very much like a database planner to figure out the most efficient way to fetch these services and this data from these relationships. So now I go into the review service and I get my data. And then I also go into the product service and I fetch the data that I need from the product service. All that easy. This isn't something that you have to write in the gateway. There's no custom code. The gateway is, I'll show you in a couple slides, a pretty thin thing. It's a very thin API layer, just like what Marc-Andre was talking about. And then we'll clean this up a little bit, and we'll show that products exist as part of a review as well because it's a reference. So I can come in here, and I can fetch the product name. And now I go all the way through reviews and into products. I can fetch all that data. And none of this work is additional work on the client to compose this. They don't have to know about the object identity of the entity behind it. They don't know how the services are orchestrated. They can just fetch the data that they need and get the data back. And it gets really exciting if you go a little bit beyond that and you start to provide more information into Federation to tell it what's going on here. And there's a lot of really cool shortcuts that I'll talk about a little bit later in the talk, but one of them that I'm showing here is being able to provide additional data because the services don't have hard edges. We have denormalized data. We probably have, a few of us have different databases that we pull from for our services, and there's some level of overlap as we store things. So you really shouldn't be penalized by this chatty server-to-server communication. You should be able to say, I can do this faster for you, which is really cool because then when I go into, for instance, the reviews, and I ask for the author and the username, let me just clean this up here for a second. Then the first thing I can do is go to the account service and get the user that I'm talking about, my identity, my login section. And then on the review service, I can ask all the way through the username. So I don't need to do an additional fetch into the author service. I can hint and tell the query planner declaratively what capabilities as a service I have and my ability to resolve them. And this is all very much the tip of the iceberg, and I'll show a little bit more in the rest of the talk about how this works, but fundamentally what you're looking at here is just GraphQL through the lens of the client, but flexibility and organization and language and deployments for the teams that build that graph and work collectively to build that data layer. So, was that an okay spacewalk for everybody? Cool. Cool. All right, so how does all this work? What were those directives? What's actually going on behind the scene? There's three kind of core concepts that power Federation that is built on top of GraphQL. The first is the idea of an entity, and an entity has a key with it. The second is the idea of type references. So this is very much part of the language. It's not really a new idea here. And the third, much like the second, is type extensions, which again is a built-in part of how you as a team can orchestrate and design your schema to work better to people who have the knowledge to support it well. So with these three things, you're able to use and build a federated graph. So what does that look like in practice? So the first and really critical thing is the idea of an entity. And like most things in our community and in all communities, this is built on ideas that have been really successful in the past. Entities are largely a new additional take on the node interface from the relay spec, which is a really foundational way to think about object identity in a graph. And it's a really powerful tool. And as we would give people the advice, like you need to use the node interface, it's a really great way to refer to things, we'd get back responses like, I think it's great, but we really don't have a single ID that we can use to reference this entity. Or this entity needs actually a little bit more data, it needs 2 keys in order to do it. It's a compound key. So what we created here with Federation is the ability to define an entity, which is a connection point in the graph, with a primary key or keys using the key directive. So in this case, the product is referred to not by an ID, but by the UPC, because fundamentally that's how we access information about a product. Once you started to build out these entities and these keys, then you can start to refer to them from other services. So once an entity becomes part of the graph, other services can say, hey, I know a little bit about this. I know enough information to get you started so that you don't have to have a new root entry field that is reviews for product. Anybody have stuff like that in their schema? Great. Y'all apparently are all excellent at schema design. Thank you, Yanni. So we see this happen just over and over again where people create these unnecessary entry points into their graph. They aren't able to really create a graph. They have essentially their REST service API just done at the root of their graph. And that kind of misses the point of how teams want to be able to work on this kind of stuff. So instead with type references, you can start to extend types and return them across service boundaries. And then, typically, because types aren't the right boundaries, teams want to be able to extend what that looks like. So this is a pretty simple method using the built-in tools within the GraphQL language to say, I, as a service, have additional information about a product. So I can use the extend keyword. I can tell you, as a service, I understand a product through its primary key of UPC. And with that, I can give you the reviews for it. So again, this is the same kind of stuff that your client teams typically do on the client side. You can move that into the server side and have still a relatively thin GraphQL layer, and you can have a graph that works in both directions. And these services can still define their capabilities well and connect things together. And with these 3 core concepts, we can create a query plan. So one of the parts of Federation is the idea of a query plan. Again, this is much like a database planner would work. Knowing the relationships between the graph and the information needed to connect them together, we can take a query that comes in, like this who am I query, and we can know that the account service can return and handle the figuring out who I am and what my username is. But in order to get the information around the reviews, I'm going to need to go to another service. So as that query comes in, I need to compile that into a query plan, cache that for the next query that comes in, make sure I'm creating the most optimized version of the way to fetch that data possible, and then I need to execute it. I need to handle errors, I need to handle back pressure, I need to be that somewhat magic, though hopefully this is making it less magic, gateway that Marc-Andre talked about yesterday. And then beyond that, the more we started to work with teams who were kind of adopting Federation early, kind of our partners that we worked with in the community, we realized there was a few additional missing pieces that teams had in the way that they wanted to relate things together. So one, like I've already mentioned, is this idea of denormalized data. It's really not uncommon, especially in enterprises, to have multiple data layers and multiple data services and have overlap between those things. So being able to use the provides directive and hint ahead of time that I have this field, or maybe I have this field and I have its child or the selection set for it. So these directives, they don't take strings, they take this idea of a field set, which is really just a GraphQL selection set. So again, you're using the GraphQL language to provide these connections together. That way it's not another additional thing for you to learn as a team. You still get validation. All of the stuff is static. And you can really build collectively without fear of, like John said, pushing a change into production. Like that doesn't have to happen. You can use the validation layer of GraphQL and extend it and build a federated validation layer. Another thing that teams needed was flexibility in how they defined the keys. So sometimes this looks like being able to use whatever UPC or SKU or something they want to. Sometimes it means that they need to be able to support multiple ways to reference an entity. So maybe the product team has to support UPC because that's the new field that they use, but historically other services understood it to be a SKU. So that team needs to be able to maintain support for those two ways to enter into the graph and understand what a product is. Maybe you have a compound key. This was especially prevalent in some of the early partners that we worked with, where the idea of fetching an entity wasn't something that was simply a primary key. In fact, sometimes it was even an ephemeral bit of data that entity type was, because it wasn't stored in the database. It was like a cart item, but they wanted to be able to reference that as part of the graph, so they needed a compound key in order to enter into it. And then one of the last things that we saw a lot were they need to be able to do composite fields. This is especially true as teams move and work on their data graph in a way that works best within the language that they want to provide it. So if they want to use a really like heavy computation engine, they're probably not going to use Node for it, but they may need information that a service that's written in Node needs. So with the requires directive, you can require information from other services to create this linked dependencies. And because this is just GraphQL, you get the added benefit of things like you can deprecate these fields. And then when you open a PR, you're going to get a deprecation warning for your linkages and your dependencies. You have to make sure that those types line up so that that service-to-service communication in whatever language you write it in, whether it's Thrift or gRPC, or if you use the kind of the default here, which is GraphQL, you have that strong statically typed nature to link those things together. So what does this architecture look like? Well, imagine that you could draw it out. It's pretty simple. It's a gateway and some services. We have a gateway that's open source. That's @Apollo/gateway. And it's a really great way. It includes this query planner and this composition algorithm and the federated execution tools. And then we have federated services. So these are services in any language that implements the Apollo Federation spec. And they can be of any scale, any size. They can be Lambda functions for all, it doesn't matter. It's whatever you want to run as a team and how you want to structure it. So the first part of that is the Apollo gateway. And this is a pretty simple, thin gateway. And instead of having manual user code that you write here where you're linking types together, you give the gateway a service list. Whether that's a list of URLs or you manually bring in the service definitions. That way the gateway knows how it can orchestrate fetches between services. And that's it. This is nothing like the existing schema stitching implementation of how that gateway looks, because those code bases are just terrible and gnarly, and we are collectively sorry for all of that. We hope this will be a lot better. It certainly has been a lot better so far in the teams that have been trying it out. And then we have the Federation spec. And this is using GraphQL to build out a way for other services and other languages to participate in Federation. And one of the key points here is, unlike schema stitching, this is really intended for first-party graphs. This isn't about, I'm going to go and pick up the GitHub schema and add it into my graph, because now you have a dependency on another company that is unaware of that, and you are not building effectively what is the right solution for your end clients. And right now, Federation is very much focused on you as a team collectively building the right graph for your company and your product. So you can run in all these different languages. As of today, we have JavaScript and Java support for Federation. And all these languages that are on here already have active discussions within their community about what does it look like to support Federation. And we're really excited to work with the rest of the community on bringing this support, because it's our opportunity collectively as a community to experiment and push the language forward in a way that doesn't require us going through a spec process, because then things would get added to the language that don't make sense, and we would miss out on really good features because that's not a process designed for rapid iteration. The community is designed for rapid iteration. So we're really excited to work with teams to implement this Federation spec together. And ultimately, having the opportunity to lead the open source team at Apollo, the reason why it's such an immense pleasure is because we get to work with all of you to work on GraphQL and to build it, and to be able to build it in a way that works for you. Apollo has always been about incremental adoption. It's always been about education and helping you understand what it is. And it's not the only way to build a graph, but it certainly is a way that we think works pretty well, and in practice has shown pretty well for the community. So we as a team are here to help you to build one graph and however many services you want to do. And Federation is our new way for you to be able to do that. Thank you. It's been a pleasure.